Alright, we're looking at the methods practice exam semester 1 in this video. Before we start, you got to have your formula sheet on you and your calculator. And you also get a double-sided cheat sheet for this exam. Okay, so question 1, we're talking about this linear thing. So is the graph a function? The answer is yes, and because it passes the vertical line test. So the vertical line test, you just chuck a bunch of vertical straight lines in there, and as long as it only hits the graph once and never more than once, then the thing is a function. State the y-intercept of the line. Alright, so it looks like the y-intercept is 3 based on the graph there. Find the gradient or slope of the line. So basically you pick any 2 points. So I might pick the points, let's go 0, 3, and I can see the x-intercept is 6, 0. And then the slope is y2 take y1 over x2 take x1. So that's going to be the two y values take each other. So that's 0 take 3, and then it's 6 take 0. So it's minus 3 over 6, which is minus a half. You can also see that if you look at this, every time you go down 1, you're going across 2. So if you look at rise over run, it's minus 1 over 2, which is the slope. So that's another way you can look at it. And basically, I just want the slope there, minus a half. Okay, so that's good. Now we can state the equation of the line. It's y equals mx plus c is the equation of the line. So that's minus a half x plus 3. Use your equation to find the x-intercept. Now we can already see that it's 6, but we'll do it formally. So I've actually got this on the formula sheet here. To find x-intercepts, you set y equal to 0. So y is minus a half x plus 3. Therefore, 0 equals minus a half x plus 3. You got like y equals 0 there. So you got half x equals 3. Therefore, x is 3 times 2. Therefore, x is 6. Done. All right, quadratic. First thing we're going to do in this is actually just get a graph of the thing. It never hurts to graph equations and have a look at that. So we'll delete that out. X squared take 4x take 5. And it looks like the graph that we're going to have to draw in a sec has windows just going from minus 10 to 10. So we'll copy that. There we go. That's a lovely graph of our quadratic. Now we don't necessarily need it graphed yet, but you can sort of see there the y-intercept is minus 5. Now to get the y-intercept, we got to set x equal to 0. So y is 0 squared, take 4 lots of 0, take 5, which is minus 5. And if you want, you can go trace on your calculator and type 0. It'll spit out y is minus 5 as well. Find the x-intercepts algebraically. So you've got to go 0 is x squared, take 4x, take 5. We're looking for two numbers that times to give minus 5 and they add to give minus 4. So those two numbers I reckon are going to be minus 5 and 1. So if we work this out, x take 5 is the first bracket and x plus 1 is the second bracket. And we can read off both these solutions. So this one is x take 5 is 0. So x is 5. And then this one is x plus 1 equals 0. So x is minus 1. And if you want to check, you can go g-solve and root. That'll give you the x-intercepts. We got one at minus 1 and one at 5. So that's good. Sketch a graph of the quadratic using the info that you found above. So we're going to put minus 1 and 5 on there as our x-intercepts. We're going to put, I think the y-intercept was minus 5 as well. So there we go. There's the y-intercept. What I might also want to put on is the minimum. So that's 2 and minus 9 for the y. Bit hard to see on the calculator, but it is just there. That's going to be the minimum point there. And then we can sort of join up our quadratic. If you want some middle points, you can get them. So maybe if I want to know what my quadratic equals at 3, I can pop that in, minus 8. If I want to know what it equals at 4, minus 5. And you can sort of use that to get a rough shape of your quadratic before you commit to joining it up. Maybe I'll even figure out what it is at 6. It looks to be at 7. So we'll just pop that one in there. And then that'll be symmetric. So that's minus 7 across there. Get a rough shape of this quadratic. Make sure that it's nice and accurate. The more points you can put in, the better, but obviously you're under a time limit, so you may or may not be able to put in a whole bunch of points. There we go. And then we put in the equation, x squared take 4x take 5. Done. So your graph needs arrows on it and the equation. State the domain and range. So the domain is going to be any real number x, because this quadratic can go left and right forever. No matter what number x is, you can always square it and times it by 4 and stuff. Nothing's going to stop you there. Usually domains where you get issues is if you're like dividing by x, and then x can't be 0. With the range, y has to be bigger than -9. So there's -9 at that point there. Y just has to be above that point. Excellent. All right. So that's good. We'll move on. All right. So this is just all sorts of working out that we're going to do here. So this one is 0 equals 2/3 of x plus 12. So if we rearrange this, I'm going to get -2/3 of x on this side, and then I'm going to get equals 12, just there. And if we divide, so x is, well, I can times by 3 and divide by 2. So 3 times 12 over -2. So x is, let's see. You can do this on the calculator. In fact, it's probably better to do that so you don't make a mistake. 3 times 12 over -2 gives you -18. There we go. And if you want to check your answer, if I do 2/3 of -18 plus 12, I should get 0. Yes, I do. Find the x-intercepts of this. So first thing we're going to do is just jump into equation mode here. Polynomial, degree 2, 3, 7, 1. Solve, and now I know what I'm expecting to get. It looks like a nasty thing. That would tell me maybe I need to use a quadratic formula. So A is 3, B is 7, and C is 1. Quadratic formula is on your formula sheet. Just lives sort of near the bottom here. But it's x is minus b plus or minus root of b squared take 4ac all over 2a. So that's -7 plus or minus root 7 squared take 4 lots of 3 and 1 all over 2 lots of 3. So that's going to give me -7 plus or minus. Now what I'm going to do is just inside the square root, or work out what all that stuff is. So that's 7 squared take 4 times 3 times 1 gives you 37 all over 6, and that's good as a final answer. And you might notice that that's what we got from polynomial solver on the calculator. So that was equation mode back there, F2, degree 2, solve, yes. So we got that. Find the x-intercepts, there they are, there's the 2. Expand and simplify this wonderful thing. All right, so this becomes -4, and we're going to FOIL it out. So 2x squared, take 6x, and then you're going to FOIL out the last bit, plus x, and then take 3. This is -4, 2x squared, take 5x, take 3. And this is -8x squared, plus 20x, and then plus 12. So if you want to check that you've got the right answer, this is a little bit of a cheeky method that you can use, but it absolutely works. You can graph both things. So you can go 2x plus 1, and then x take 3. And then you can graph, we'll just draw it and see what that looks like, sort of that quadratic thing. And then we can also graph the other thing that we just found. So the other thing we just found is -8x squared plus 20x plus 12. Graph that and have a look, and it goes right over the top. So as long as those graphs completely overlap, you've done the expansion right. Okay, f of x is 3x plus 1, find f of 2. So this is just checking that you know what function notation means. What that means is x is 2, find y, essentially. So f of 2 is 3 squared plus 1, which is 9 plus 1, which is 10. Solve cos x equals -1/2. So one solution is really easy to get. So we're just going to make sure that we're in radians. I'm not. I'm in degrees up the top there. So shift, set up, go down, hit rad for radians. And we're going to go shift cos for inverse cos, and we're going to go -1/2. There we go. So you get 2/3 of pi. So x is inverse cos of -1/2, which is 2 pi over 3. So that's one angle. And 2 pi over 3, you can convert it to degrees if you want. So that would be timesing by 180 over pi, just to have a look at what that is. It's 120. So up here would be like 90 degrees. So 120 is a little bit further. So one of our angles is sort of up there. And then we can hopefully see that if we sort of map down what the x coordinate is, that point should be minus a half. Because remember, cos is x and sine is like the y value. So we're going to find another point where cos is minus a half. It appears to be this point down here. So the blue angle, that is 2 pi over 3. And we would really like to get also this angle that I've drawn in black there. Now, how do we get that? Well, essentially, you've got to notice that this is 2 pi over 3 as well, because the whole thing's symmetric. Therefore, the other angle is, so it's a whole way around the circle, 2 pi. It's like 360 degrees. Take 2 pi over 3. So essentially what we're doing to get that black angle is we're going the whole way around. So that's 2 pi. And then we're taking 2 pi over 3. And that leaves us with the black angle in there. Okay. So we can work that out. Again, you can do this by hand if you want, and I do recommend practicing it so that you get nice and quick at these questions. But if you're actually in an exam, you just don't want to make a mistake. It's 4 pi over 3. Over 3. Okay, so these are the x could be these two. So let's check it. So if we do cos of 2 pi over 3, we're going to get minus a half. And if I do cos of 4 pi over 3, I get minus a half. Groovy. All right, triangle. Calculate the missing side length. So what I'm going to do is label this triangle. It doesn't matter too much how you label it, but I'm just going to label this as like A and B. So that's big A and big B. Just remember that the big A needs to be across from little a, for example. Big letters angles, little letters are side lengths. So we've got to find something where we only need one angle. Now on your formula sheet in general, the cosine rule is for dealing with things with one angle, and the sine rule is for dealing with things with two angles. So we got one angle here. So we're going to use the cosine rule. Cosine rule tells us c squared is a squared plus b squared, take 2ab cos of c. So that c squared equals 12 squared plus 8 squared. Take 2 times 12 times 8 times cos of 110. And we can work out what c squared equals. Now I want you to pop this entire thing into your calculator. So don't work it out piece by piece, just chuck the whole thing. All right, now I'm about to make a mistake because I'm still in radians from the last question. So we just got to go shift menu and swap back to degrees and hit enter on that. So 273.667. So that's still an approximately equal sign because I've rounded that down. But so C roughly equals the square root of that. So that roughly equals, now I'm going to go square root and really importantly, shift answer to put the whole answer in, not just the rounded version. 16.5. One thing about exams, you need to write everything to 3 significant figures. So 16.5 is 1, 2, 3 significant figures. 16.5 meters. Now let's check our lengths. 12 and 8, 16.5 sounds about right. If my length was like 500, you'd know you'd done something wrong. Calculate the other two angles in the triangle. So one of the angles we're going to get just from the sine rule. So let's go sine A over A is sine C over C. Now we know what 3 out of 4 of those things are. We don't know what big A is, but I do know what little a is. That's 12. And I do know what big C is. That's 110. Over, and little c we just worked out 16.5. Again, just make sure you use the full version. So I'm going to use approximate here. So sine of A is 12 times all that. And let's see what we can do. So A is inverse sine. Yeah. Now I'm actually going to show you a cool strategy. This number that I just got, 16.542. I'm going to hit the little arrow here above the blue button, and I'm going to store that in alpha C. So now every time I use C in an equation, like alpha C, it'll just spit out that number. And I don't have to worry about typing in the whole thing. So what I want to do to figure out A is I need to go inverse sine of 12 times, and then it's going to be sine 110 over. Now it's 16.5. That's the C value I just got. There we go. So that'll save you a whole bunch of time. It's a little bit annoying to do it first, but once you get used to it, it saves heaps of time in tests and exams. 42.97. Now, you absolutely can, to find the other angle, do the sine rule again, but there's a much quicker method to do it. 110 plus 42.97 plus the angle B should equal 180. And this is sum of angles in our triangle ABC. Okay, so therefore B has got to be 180 take 110 take 42.97. So again, I might actually do that strategy, store that answer in B, because that was actually I'm not, that'll get confusing because C was the length, not the angle. But anyway, let's just do 180 take 110 take and then shift answer for the answer we just got. Bam, 27.0. Beautiful. So if we want on this triangle, A was 42.97. I'm actually just going to write this as 43.0 because that's three significant figures. And then this is 27.0. Now, yes, that sort of looks like it's the right sort of sizes for those. So A was 43.0. That's three significant figures. All right, calculate the area of the triangle. Now, really importantly, I'm going to recommend that you don't use answers that you worked out yourself, just in case you had them wrong. You will get follow-through marks. So if, for example, this number was wrong, but we used it correctly in the next question, you still get the 3 marks there. But for the area of the triangle, we've got 12, 8, and 110. So we're going to use those. Area is half AB sine of C. All right. That's half times 12 times 8 times sine of 110. And we can work out what that is. So 0.5 times 12 times 8 times sine of 110 gives us 45.1. It's in meters squared. Yeah, it is. Cool. So there we go. All right. Lawn mowing. So there it is, 150, 300. It's 150 per meter squared. So that next is 450, and the next one is 600. Sketch a graph. So I'm going to be a bit cheeky on my axis. I'm going to go up by 150s. 300, 450, 600, I guess 750, 900. You don't have to write in every point, but you can write in like every second one, for example, maybe. So it'll be like 1500 there. And X can go, I'll give you an example of how you write in every second point. 2, 4, 6, 8, 10, just like that. Okay, and make sure you get a ruler when you do this. There you go, like an arrow on the end, and this is just CA. We don't know what the equation is yet, but we're about to find it. State the equation. So CA is 150 times X. We better go and, so CA is in dollars. I might just go cost. And this is X in meters squared. Okay, that's good. And now that I've got the equation, CA is 150X, I can just label it back up there. Okay, are CA and X directly proportional? Yes. So to be directly proportional, it needs to be linear, which it is, and it goes through. Oh, so yes, it does. Therefore, CA and X are directly proportional. The other thing you can do, so there's two ways to tell. On the table, if we do divide those two, then you'll get the same number each time. You'll always get 150. And the equation looks like just essentially in the form y is mx. So that's what directly proportional looks like. All right, company B has that. So we're going to complete this table for company B. Honestly, I'm going to be a little bit cheeky here. So what you can do is you just want to make sure whenever I give you a table like this, the reason I fill in a few values is actually to make sure you know you're doing it right. So if I do 50 times 2 plus 10, I should get that 629 number, which after hitting S to D, yes I do. So make sure that you're actually doing it right. 50 times 3, 758.95. And if we go times 4, and S to D that, 869.48. Groovy. All right, sketch graph for CB on the previous page. So this is what I was saying I could be a little bit cheeky with before. If you know that it's coming up, you can actually sketch the graphs in advance. So 150x and then 60 root 50x plus 10. Okay, so let's match our window. We went from 0 to 10 on the x, and we went from 0 to 50. Ooh, I shouldn't have touched that. 0 to 10 on the x. And we're going to go for the y's, 0 to 1500. And then if we graph that, we'll see in the blue there was our original graph, and then in the red will be our new graph. So what I was saying you could do before is you can absolutely just go trace and then type 1. And on the red graph, you'll see it's 464.76. You can go trace in 2, and if you scroll up to the red graph, you'll see it's 629.28. So you can use trace to fill out this table as well. Okay, sketch a graph. So what I'm going to do is I'm actually going to, just to be really precise, I'm actually going to trace every, let's go second dot. So on the red graph, 189.736. So for this one, that's going to be a little bit above there. So that's our first point. I'm going to trace 2 and see what we get. This is 629.28. Should be about there for 2. I'm going to trace 4. And you can see sort of what I'm doing here is mapping it out so that I'm just plotting the dots on there like we did with the quadratic so that you've got a good shape. 869, so there it is about there. Trace at 6, 900. That's easy. Oh, no, it's not, because let's get rid of that. I haven't scrolled up. 1056. So that's just a little bit above there. The other important point I might find is the intersection. So intersect there. 8.195. So it's a little bit after 8 that they intersect, just a little bit. And then that's probably enough dots to get a good picture of this. So CB is 60 root 50x plus 10. Cool. So make sure you got both those on here. Use your calculator to find the approximate where CA and CB meet. So we've already found that here, 8.19 or 8.20 and 1229. Now this is what I don't like about 3 significant figures. Technically that one there is the 4 significant figures, but I'm not going to round it up to 1230. That would be a bit silly. Okay, fully interpret what this means. So if buying, I might type this, if buying 8.20 meters of lawn, both companies cost the same. Any less than this means company A is cheaper, and any more means company B is cheaper, and at this special point where they cost the same, at 12.29. So you could also make a comment something like company B seems to encourage buying in bulk. So like with company A, you're just paying $150 per square meter. But with company B, you can see that the graph is getting less steep. So if you buy like heaps of lawn, you're better off going with company B. So that's somewhat what you need. So pretty much all that. Okay, next question. So we got a map of the Eyre Peninsula. You got that circle equation on there. Draw another circle with this map. So really importantly, again, I've done this original circle so that you can kind of remember how to do circles just before you launch into doing the second one. This circle here has a center at 20 and 25, so wouldn't it? And it's got a radius of 19. So you can see that like it's 19 of those tiny little squares. Well, it goes up to 42 from 25. No, that's 44. It goes up to 44 from 25. So really it's 19 units, and each square is 2 units. So it's like, what is it? 9.5 little squares that it goes up. Okay. Next one, X take 39 and Y take 25 would be centered at that same height. It's just centered over here at Y. And that's got to equal 10. So 25, we're going to go up to 35. So let's go up to 35, kind of like there. Let's go across. So we were at 39, so we're going to go down to 29, so that's here. Basically what I'm trying to do is go 5 squares in each direction. So there we go. So that is circle 2. All right, a stray emu has escaped the Whyalla airport. This is real, by the way. It actually happened. Well, it went into the airport. It's running away across the Eyre Peninsula. So the emu's got a tracking chip. It's reported there and there. So we're going to use the circles to visually find where the emu could be. So basically what this question is asking you to do is to find the 2 spots where the emu could be. So it's this spot here or this spot here. So the approximate coordinates of these points. So they're up the top. So they both look to be at 37 on the x-axis, and they might, the first one is at 33. So 37 and 33 would be the first one, and 37 and let's see, 18. All right, groovy. So which of your 2 points do you think the emu is going to be? So it will probably be in the top one. So 37, 33, because emus can't swim. I think they can't swim. Anyway, they wouldn't swim out that far. That bottom point's in the ocean. Emu's not going to be there. Unless it's like boarded the ferry or something, which is terrifying. All right, the trackers want to actually find the emu. So we've got a rough approximate from the map, but they'd like, you know, each unit on this map is 100 kilometers, 10 kilometers. So if we're off by a little bit, then it's going to be big. So let's see. We got both circle equations. So first thing we'll do is we'll write both those in. X take 20 squared y take 25 squared, and 19 squared. So that's circle 1. And I'm going to actually rearrange this to y take 25 squared equals 19 squared take x take 20 squared. That's like a rearrangement. You take x take 20 squared from both sides. With circle 2, that looks like x take 39 squared. Y take 25 squared. 10 squared. We can rearrange this to y take 25 squared is 10 squared take x take 39 squared. All right. Wonderful. So I've sort of done the first step, and this is why I gave you the hints, because it's a pretty tricky question. Set the two right-hand sides equal to each other. So what you might notice is that over here, both of the left-hand sides equal y take 25 squared. If they both equal the same thing, then that means these two should equal the same thing on the right-hand side. So therefore, 19 squared take x take 20 squared would equal 10 squared take x take 39 squared. And these both equal y take 25 squared. Groovy. All right. So we can work out what these numbers are. So if we just go back into the menu and I look at 19 squared is going to give me 361. Now, x take 20 squared. What we're going to be using here is this equation. A take b squared is a squared take 2ab plus b squared. So that's, I'm going to keep it in brackets, x squared take 2 lots of 20 and x plus 20 squared, which is 400. I might actually just leave those 20 squared. Equals, so 10 squared is 100, and we're going to do the same thing here. X squared take 2 lots of 39 and x plus 39 squared. So this is 361 take, so it's take x squared. This will become plus 40x in that middle term, and the last term will become take 400. 20 squared is 400, and we've got to factor the minus into all those. Equals, so we got 100, take x squared, 2 lots of 39 is going to be 78, x plus, and I cannot do 39 squared in my head, 1521. Yeah, I'm expanding that minus into each term, so it's going to be a plus in the middle, and then that will flip to a minus. Okay. Now, we can take away x squared from both sides. Oh, sorry, add x squared to both sides, and they'll cancel off. And then we can start grouping like terms. So on the left-hand side here, I'm left with 40x. 361 take 400 is minus 39. And then on the right here, I've got 78x, and we've got 100 take 1521. Let's work out what that is. Minus 1421. All right, what I'd like to do is I'd like to get all the x's on the left and all the numbers on the right. So we're going to take 78x from both sides. So 40 take 78. It's going to give us minus 38x over here. And we're going to get minus 1421 plus 39. Oops, minus 1421 plus 39 gives us minus 1382. Okay, so x is minus 1382 over minus 38. So we can do that. Minus 1382 and minus 38. So x seems to be 36.4. Okay, which matches pretty closely to that 37. Wonderful. Then if we want to get y after, so use one of these two equations. I might use the bottom one. Y take 25 squared is So this is from circle 2. 10 squared take x take 39 squared. So that's 100. Take, so 36.4, well, whatever that number is, take 39. So that's minus 2.63 all squared, and we'll square that. So this is 100 take 6.93, which all these should really be approximates. Roughly equals, so we'll go 100 take that answer we just got, 93.1. So this is y take 25 squared is 93.1. Therefore, y take 25 would have to equal plus or minus the root of 93.1, and this is an approximate. So we're going to take the square root of that answer. So 9.65. All right. And then y's got to be 25 plus or minus that. Okay. So if we go, we'll go plus 25. So that's one y value, 34.6. And if I go 25, take that whole big number, 9.64, 6475 to 7779, 15.4. Cool. And then this is a very tricky question, by the way. I won't sugarcoat it. It's good practice for some unfamiliar stuff, which you are going to see in an exam. So we got 36.4 with 34.6, or 36.4 with 15.4. So those are your two answers. And they pretty much match where we thought. Maybe my heights on the circles are a little bit lopsided, but you can see they're pretty much where they are. And obviously my points aren't going to be perfect because I just drew them. All right, next up we got this lovely question about pendulums. So we basically just have to find the equation of this graph. So a rough estimate of the period of the graph. So first of all, with the period, you got to find 2 points which are consistent. So I'm going to go with the minimums there, and they look to be 0.4 seconds apart. So 0.4 seconds. Now we need to find A, B, C, and D. Well, B is 2 pi over the period, so that's good. We got that. A is the total height from the center up to the top. So the graph isn't shifted up or down at all. It's just from the center up to the top. So that's going to be 3 for the A value. And D is actually going to be 0. It hasn't moved up or down at all. If you do want formulas for A and D, like formal formulas, A is max take min over 2. And D is max plus min over 2, if you want. Okay, so C is, when we get C, we're looking for the wonderful spot where it's right in the center, but coming back up, and then whatever that value is the X value. So that looks to be happening at 0.1. So C is 0.1. So we're going to have S of T is the A value, so 3 sine of 2 pi over 0.4, T take 0.1, and there's no plus D at the end. All right, so what we can do is we can actually graph this on the calculator and get a check that it works. So we'll delete out all the old graphs there. Make sure that we're in radians. So I'm just going to go back and set myself to radians whenever we do a graph for trig. Graph that, and I'm going to get 3 sine of 2 pi 0.4 x take 0.1. Graph that. We'll set our window to be the same. So it looks like t might go from 0 to 0.5, and s of t might go from -6 to 6. And then hopefully if I graph that, it should look the same, which it does. That's good. What's the total horizontal distance covered? So from, this is a bit of a curveball question, but it goes from -3 up to +3 centimeters. So that goes up by 6 centimeters. And then from here down to here, it goes back -6 centimeters. And what am I asking for? The first 0.5 seconds. So it should go through to that point there. And then it should go back up 3 centimeters. So you're going to get 6 plus 6 plus 3, which is 15 centimeters in total. Bit of a tricky question, that one. But if you sort of imagine the pendulum swinging back and forth, it's done, sort of started here, it's done one full swing, and then it's gone halfway back. So that's 6, 6, and 3, like that. Okay, conjecture time. So there's our two lines. Show algebraically the lines intersected x equals 2. So those are our two lines. Y is 2x and y is x plus 2. So we're going to set 2x equals x plus 2. So we're going to take x from both sides. So take x and take x. So you're going to get x is 2. So take x on both sides. That's all you need to do. Groovy. All right, in general, there we go. It's a pattern, develop a conjecture. So it looks like whatever the a value is on the top of that fraction. So x is a over, and then whatever's on the bottom is 1 less. So a take 1. So we could have the lines y is ax and y is x plus a intersect at that one. Preview conjecture. So y is ax and y is x plus a. So we got to set ax equal to x plus a for the lines to intersect because they both equal y, essentially. That's why you can do that. Therefore, ax take x is a. So this is going to be take x both sides. So because we're doing a proof, I'm really explaining what we're doing. So we're going to pull out x as a common factor. So we're left with a take 1. X as a common factor, and then x is a over a take 1. So we're going to divide by a take 1 both sides. And then you put a little square and you color it in because we just finished the proof. Okay, so there is one value of a where our conjecture doesn't work due to dividing by 0. So if a take 1 was 0, a would have to be 1. Find this value of a, there it is. Explain why the lines won't intersect. So the line y equals ax becomes just y equals x if a is 1. And the line y equals x plus a will just become x plus 1. And if we look, we can have that as like 1 and 2, 1 and 2. And if we graph both our lines, so the first line is going to be y equals x. And then the second line is going to be y equals x plus 1. And what do you know? Lines are parallel, therefore no intersection. Find a formula for the y coordinate. So x was a over a take 1. And to get the y value, we're going to use ax is probably going to be easier. So there it is. And then we can just plug in the x value. So that's a, and then it's a over a take 1, which is a squared over a take 1. So that would be the y value of the line. So the actual point of intersection is a over a take 1 and a squared over a take 1. Beautiful. All right. Oh boy, this one's really good. I've got an angle notation reminder, so just throughout this whole question, angle ABC would be that angle in there that it makes. Let's just help you out a little bit. Draw a line connecting the center of the lake O with the point Q and explain why OQP is theta. Well, this is a radius of the circle O to Q. OQ is the radius, which is 2 kilometers. Therefore, triangle OQP is isosceles. Therefore, the two base angles, like if you ever have an isosceles triangle, those two angles are the same in the bottom left and bottom right. So our triangles are oriented a bit differently, but angle OQP equals angle OPQ, which is theta. Okay, hence explain why that bottom angle there is pi take 2 theta. So if we look at the triangle on the bottom, so we've got theta and theta there. So if I just let angle QOP equal x, so we're going to have x plus theta is 180, but it's not 180 because we're in radians, it's pi. So x plus 2 theta is pi, so x is pi take 2 theta. And then we've got this bottom bit, so here's a point O, and I've just learned that that's pi take 2 theta. And then here's S, and here's Q, and here's P. So we're going to say let angle QOS equal Y. We're going to have Y plus pi take 2 theta is, now this is going to be 180 again, because it's a straight line. But remember, this is just pi. So this is a straight line. It's a pi because we're in radians, by the way. All right, so I can rearrange that. So y, the pi's will cancel off, so y take 2 theta is 0, so y is 2 theta. Now I've given you a diagram here with basically all the messy drawings gotten rid of, and now we just got those 3 angles we found in there. Find the arc length from Q to S in terms of theta. So we have a formula for arc length that's on here. L is theta r, and this is why I got you to do the questions in radians. So basically, there's Q, there's S, there's 2 theta, and then there's 2 kilometers. So the angle is 2 theta, and then the length is 2, so that's 4 theta. There we go. Draw a straight line from Q to S. So we've got to draw this straight line here. This triangle is isosceles again. So if we look at Q and S and O, we've got isosceles, there's 2 theta. So I'm going to say let angle OQS equal Z. So that's a Z in there. Then the other angle equals Z, so O less Q equals Z, because triangle OQS is isosceles. So it's like what we did before. It's like what we did before with the very first bit, how you could spot that this angle and that angle were equal in the triangle. Because that was isosceles, this triangle is also isosceles. So we've got 2 theta plus z equals pi, and this is sum of angles in triangle OQS. So 2 theta plus 2z is pi. So 2z is pi take 2 theta. So z is pi over 2 take theta, so halve everything. So if we look up here, we've now learnt that this angle in here is pi over 2 take theta. And what are we trying to do? Show that PQS is pi over 2. Therefore, angle PQS has to be two angles added together. So PQO plus OQS. So this is theta plus pi over 2 take theta, which is pi over 2. Or in other words, that's 90 degrees. So what we've learned is that that angle up there is 90 degrees now. Okay. From D, we can draw that. So that's a simplified diagram, show that PQ is 4 cos theta. So really, if we label this triangle as hype, op, adjacent, cos of theta would have to be adjacent over hypotenuse, which is PQ over the hypotenuse is 2 plus 2, so it's 4. Therefore, PQ is 4 cos theta. Wonderful. All right, so we've got these two lengths. So that one there is 4 cos of theta. And that one all around there we worked out was 4 theta just before. Let's see, what did we work out here? Okay, so time is distance over speed. And you've probably seen where all this formula is coming from now. So T is PQ over water speed, essentially, plus Q to S over land speed. So this is 4 cos theta all over. Now the water speed is 3, and I said that way up the top of the question. So here you can go across the lake at 3 kilometers per hour, and you can go across land at 6 kilometers per hour. So that's over 3 there, and plus 4 theta over 6. Okay, now we're going to graph it. So if we do a graph of this, let's see, I'm going to exit out. We just graph that whole thing. So it is 4 cos of, you've got to use x instead of theta, over 3 plus, and then it's 4 and x over 6. There we go, draw that. Wonderful. You get a lovely graph there. So theta realistically should go from 0 to, let's go up to pi. I don't see it being any bigger than 180 degrees. And y should go from 0 to, oh, let's try keeping it at 6 and see what happens. Make sure you're in radians. There you go. Wonderful. So you can see there's like a little line here. So let's see. If we look for the minimum time, it's going to be, so shift G solve min. It's going to be over here, 2.617. 2.617 and 0.590. So find the minimum possible time for papyrus to reach sands. So the min time is 0.590 hours, which we'll get minutes in a second, and the angle is about 2.62 radians. Okay, so let's go and we'll get approximates for those. So 0.590 times 60, that converts us into minutes, so it's about 35.4 mins. And just in case you're curious, 2.62 times by 180 over pi. So that's how we convert back into degrees, about 150 degrees. So if we look at this circle, it's going to look like you'll travel out pretty quickly, and then you'll like walk along the edge there. So very little water time is the answer there. All right, now, I won't lie, that was a brutal question, very difficult, but I really want to point out about this. Notice that if you couldn't get part A, you can still do part B. If you couldn't get part B, you can still do part C. That's why a lot of these are show that questions. It's not to make it nasty for you, it's to let you keep going on with the question. And like, if you're really confident with graphing on your calculator, you can still do part G. If you're really confident with distances and speeds, you can still do F. And if you're confident with SOHCAHTOA, you can still do E. So don't just give up on a question if you can't do part A. Do try and get some marks regardless. And that's the end of the exam.